for this example, we have this structure or beam with this specified geometry. Now we have the dimensions from the wall here to the first bending point, which is 4 feet, and then we have a 45-degree angle drop of that beam that goes for 3 feet, and the forces being applied is 600 pounds, which is a foot from the right hand side. Now, the question here is what is the moment that this force causes with respect to point O in this case? So, now the first thing is we know the force right off the bat, right? Because it's given the problem statement. Now, the question here is what is the distance that is perpendicular to this force to the point O here, which is our reference point? Well, we have the necessary dimensions here. We have that the force is about a foot from the right hand side, but the question is, we could actually draw the line of action of that force. You keep on going up, keep on drawing it, and we see that the perpendicular distance would be the 4 feet plus this some unknown distance d here. So 4 feet plus d would be that perpendicular distance with respect to this force here. Remember, the perpendicular distance is with respect to the line of action of the force. So you could actually draw this arrow all the way up, all the way down, and try to find that distance that's perpendicular to this force to the reference point O. So with practice, this gets a little bit easier to identify that distance. But in this case, we should solve for d, add that to our 4 feet, and that would be our perpendicular distance to solve for the moment itself. So right here we have part of a triangle. Let me go ahead and draw it on the left hand side just so it could be easier to see. So here is our right triangle. We see that this distance here is 3 feet, which is what I'm drawing here in the structure itself, 3 feet, and we have this 600-pound force being applied somewhere here, but we know with respect to the right side that it's about a distance of 1 foot here. We know that this is 45 degrees. Since this is 90, this means that this angle is also 45 degrees here. So now we should solve for the total length here where the force is. So we have 1 foot plus this unknown distance d here. So we need to solve for the d portion. So since we know the length of the hypotenuse here, we just do a simple cosine and solve for the total distance here. So the total footage of the bottom side of this triangle is 2.121 feet. Now, what d is equal to this total footage minus this 1 feet, right? 1 foot. So d must equal to 1.121 feet. So now that we have d, we add it to the 4 feet over here, and that's our perpendicular distance. So our perpendicular distance is 4 plus 1.121, which gives us 5.121 feet. And our moment is, so our moment with respect to point O is 3,073 pound foot. So this is our moment.